Morning everyone. Today we're starting 8.6. It's writing and graphing exponential decay functions still. So what we're going to talk about today is we're going to start by reviewing exponential growth and exponential decay. So exponential growth is y equals ab to the power x, where a is greater than 0 and b is greater than 1. So our exponential growth equations are going to look like a curve going up. Exponential decay functions is still y equals a times b to the x, with a greater than 0 and b greater than 0 but less than 1. So it's going to be a decimal or a fraction in between 0 and 1. Now a decay function is going to be a curve going down. So if we look at these two functions that we have down at the bottom, I'm going to erase this for now. It says, tell whether the graph represents exponential growth or exponential decay, then write a rule for the function. So if I take a look at this first one, I see that this one's going upwards. So I know that this is exponential growth. Now I need to write a rule for this function, and we need to write it in y equals a times b to the x power. Well, I know that a is what y is when x equals 0, and I see that x equals 0 right there. So I must know that my a is 10. So we have y equals 10 times, now we don't know what b is yet, but we do know that we have 1 and 12, which 1 is x, y is 12. So what we can do is, because we now know what x and what y is, we can put these in for our equation. So what we would have then, I'm just going to erase this for now, and this. So we would have y, well, instead that would be 12, equals, we said that a was 10, times b, and we don't know b, but we do know x, which is 1. So what we can do then is we need to just divide the 10. If we divide the 10, what we get is 1.2 equals b. So our equation then would be y equals 10 times 1.2 to the power x. Now the reason we just had to divide is that this is b to the 1 power. So basically that's just saying that it's going to stay like that. We could find the square root to the 1 power of 12, or of 1.2, but it was just going to be the same thing. So this next one, we have x as 0. So that means that a is 8. So y equals 8 times b to the x power. Now we know that x then is 1, and we have a 4 of y. So we can just plug those into our equation. X is 1, so I'm going to erase my x and put a 1 in there. Actually, I'll just rewrite this. Y, instead of y though, we're going to have 4 equals 8 times b. Now instead of x, we're going to have 1. So we need to divide by 8 because it's being multiplied. What we get then is b equals 1/2, which is in between 0 and 1. So we know that our equation could be y equals 8 times 1/2 to the power x. Next one, this is going down, so this is a decay function. So I know that my a is going to be between 1 and 0. I wrote this in the worst spot I could, so I'm just going to erase that. A has to be, B has to be greater than 0, but less than 1. So we see that we have a 0 here at 0, 6. That means a is our 6. So we have y equals 6 times b to the power x. If I go to 1, my 1 is x, my y is 4.8. So I'd have 4.8 equals 6 times b to the power 1. Now, this is being multiplied by the b, so I'm going to divide 6. And we get b equals 4.8 divided by 6. You're probably going to need a calculator for these ones. 0.8. So that gives me our b. So then our equation is y equals 6 times 0.8 to the power x. Alright, now I want you to figure out that next one. Make sure you figure out if it's exponential growth or exponential decay first. Alright, now we are going to graph y equals 5 times 0.4 to the power x and compare that with the graph of y equals 0.4 to the power x. Well, I'm going to start with 0.4 to the power x. Now I know that 0.4 to the power 0 is going to give me 1. So I'm going to put 1 there. 0.4 to the power 1 is still going to be 0.4. 0.4 to the power 2 gives me 0.16. 0.4 to the power negative 1, 2.5. Now I'm just putting all of these in my calculator because I think that's the easiest to do. So you guys can do that as well. 0.4 to the power negative 2, which gives me 6.25. So I'm going to graph this line. So we need to start off with, well actually let's figure out what the other one is first before we graph, because we're going to need to put numbers on our graph based on what we get. So now if I would put 0 in for our x, we would have 5 times 0.4 to the power 0, which that is going to be 1 times 5. So that's going to equal 5 at 0. Then I'm just going to put the rest of them in my calculator. 5 times 0.4 to the power 1 gives me 2. 5 times 0.4 to the power 2 gives me 0.8. 5 times 0.4 to the power negative 1, that gives me 12.5. And 5 times 0.4 to the power negative 2 gives me 31.25. So, if we graph these then, we're going to have a negative 1 and a negative 2 for sure. So I'm going to make my y-axis right here. So we can have a negative 1 and a negative 2. Then this would be 0, 1, 2, 3, 4, and 5. So then if we go up, looks like our highest number is 31.25. So I'm going to go up by 5. So I'm going to go 5, 10, 15, 20, 25, 30, and 35. So if I'm going to graph this first one here then, negative 2 is at 6.25, so probably about there. Negative 1 is at 2.5, so halfway there. 0 is at 1. Now this graph is going like this. It's never going to touch 0. And it's going to go up. It's still a decay function because it's going down from left to right. The next one starts at 0.5. At negative 1, it's at 12.5. At negative 2, it's at 31.25. At 1, it's at 2. And 2 is at 0.8. So this one is doing the same curve, but it's just starting a little bit higher. We call that our second line is vertically stretched. Now it says, what is the decay rate? Well, the decay rate is the same thing for both of these, which is 0.4. Alright, now I want you guys to try this one on your own. You're comparing it to y equals 1/2 to the power x. This one you have y equals 3 times 1/2 to the power x, and y equals negative 1/3 times 1/2 to the power x. So I would advise you to fill out the table first and then graph it. Alright, we need to tell whether this table represents an exponential function. You gotta look at the top first. These are going up by 1. They're being added each time. So that's good. That's fine. We can do that. Now 2 to 8, that's being multiplied by 4. 8 to 32, that's being multiplied by 4. And 32 to 128, that's also being multiplied by 4. So this one is exponential. It's being multiplied. So y equals, now a is where x equals 0. We're looking for the y where x equals 0. So a is going to be 8 times b. Now b is what's being multiplied by, and it's being multiplied by 4. So it's 4 to the power x. So 8 times 4 to the power x. Here on this one, on the top, we're still adding 1 every time. But negative 11 to negative 7, that's being added. 4 of them are being added. Negative 7 to negative 3, we're adding 4 again. Negative 3 to 1, we're adding 4. So if we're adding, this function is not exponential. It's not exponential. Alright, we're going to skip this one for now and go on to slide 7. Now we have y equals a times 1 minus r to the power t. Now this is a exponential decay equation. So when we have an exponential decay, what we are going to do is use this equation to solve it. So it says you buy a computer for $3,000. It depreciates at the rate of 20% per year. Find the value of the computer for the given year. So we need to come up with our equation first. We have y equals, now a is our initial amount. So a is our 3,000. That's where we began. We bought the computer for 3,000. So $3,000 times 1 minus, now the r is what it's depreciating at. So depreciating means going down. It's going down 20% each year. Now we're writing that as a decimal, so that's 0.2, and then times to the power t. So here's our equation. A says we're looking for after 1 year. So we're going to have y equals 3,000, 1 minus 0.2 to the power 1, because we're looking for it for 1 year. So for 1 year, y is going to be, now put this into your calculator, 3,000 parenthesis 1 minus 0.2 to the power 1. We get 2,400. So after 1 year, this computer is worth $2,400. B, y equals 3,000 times 1 minus 0.2 to the power 3 this time, because b is after 3 years. So put that in your calculator. 3,000 parenthesis 1 minus 0.2 to the power 3. Y equals 1536. So after 3 years, it's worth $1,536. And finally, C, y equals 3,000, 1 minus 0.2. C says after 5 years, so after 5 years then. So 3,000, 1 minus 0.2 to the 5th power, y equals $983.04. So after 5 years, that $3,000 computer is only worth $983.04. Alright, finally, you guys can try this one on your own. Go back to slide 4 or slide 3 to help you if you get stuck. So you're graphing and comparing with the graph y equals 1/4 to